Hello, this is Dr. Mode, and today's lesson in chemistry is on Gibbs free energy. Our scripture verse from today comes from Psalm chapter 149, verse 1. Praise to the Lord, sing to the Lord a new song, and his praise in the assembly of the saints. So I chose this verse today because we are not able to go to church right now, and we're kind of missing the assembly of the saints. So this is the last lesson in chapter 15, which means we're having a test next. So the essential questions for these lessons in this section are, what is the difference between spontaneous and non-spontaneous processes? And how do changes in entropy and free energy determine the spontaneity of chemical reactions and other processes? Irreversible processes turn order into disorder, and the entropy of the universe increases. For any spontaneous process, delta S of the universe is greater than 0. Delta S of the universe tends to be positive for reactions and processes under the following conditions. 1. The reaction or process is exothermic, delta H is negative, and delta S of the surroundings is positive. And number 2, the entropy of the system increases, so delta S of the system is positive. Gibbs free energy. So here's the equation for Gibbs free energy. Delta G equals delta H minus T times delta S. Gibbs free energy is the available energy in a chemical reaction. Systems have a tendency to achieve as low of a free energy state as possible. The Gibbs free energy number is how far away the current system is from this state. It is analogous to a number line, with 0 being the final state. Scientists use Gibbs free energy to determine the energy in a system that can be used. The sign of Gibbs free energy. A negative Gibbs number indicates that you can get energy out of the reaction. It is a favorable reaction, which means that the chemical reaction wants to move towards its lower state. A positive Gibbs number shows that you must put energy in to get energy out. An example can be seen in respiration. The Gibbs value of 1 mole of glucose is negative 2,870 kilojoules. This means that we can get 2,870 kilojoules of energy from 1 mole of glucose. This means if we put in energy in respiration, we can theoretically get 2,870 kilojoules out of the 1 mole of glucose. So now we're going to calculate Gibbs free energy using the equation that I gave you previously. So we're going to look at the reaction where nitrogen gas reacts with hydrogen gas to form ammonia. So the delta H of the system is negative 91.8 kilojoules. The delta S of the system is negative 197 joules per kilogram, but we need to get both of these numbers in the same units. So what we'll do is we'll divide by 1,000 to get negative 0.197 kilojoules per Kelvin. And then we're going to use our equation, delta G equals delta H minus T times delta S, and plug in for delta H, T, and delta S. We're just going to assume that the temperature is room temperature. So We're going to plug in 298 Kelvin for that. The delta H, we've plugged in the delta S here in the converted unit. And when we simplify, we find that the delta G of the system is negative 33.1 kilojoules. Okay, so this table right here looks at the delta H and the delta S that you can plug in and their signs and how that affects the delta G of the system. So if you have a negative delta H and your delta S is positive, because remember in the equation we subtract the delta S, if both of these end up being we have a negative and a positive, and the delta S, when we plug in a positive number, becomes negative, that always results in a negative delta G. So that means that the reaction is always spontaneous at any temperature that you plug in. So if you look at the rest of this table, the second line shows if you have a negative and negative, well, delta G could be positive or negative, and it's going to depend on the temperature. So this is going to result in a spontaneous reaction at lower temperatures. Our positive and positive is going to result in a negative or a positive, and it's going to result in a spontaneous reaction at high temperatures. And then if we have a positive delta H and a negative delta S, it's always going to result in a delta G that is positive, and you will never have a spontaneous reaction with that scenario.